okay now?
Yes.
Good morning, students. Today we are going to produce video number 7. So example 2, we are seeing a mechanics. Example 2, I read two forces, P and Q, act at a point. The magnitude of P is 24 Newton. And the magnitude of Q is 30 Newton. 30 Newton. If P acts in the direction of 30 degrees northeast and Q acts in the direction of 60 degrees southeast, find 1. The horizontal and vertical component of the resultant force. The horizontal and vertical component of the resultant force. 2. The magnitude of the resultant force. 3. The direction of the resultant force. So here, solution. The first thing is to draw the first diagram. The first thing is to draw the first diagram. That's X. That is Y. Y. Now, so we have the first force, P, which is 24 Newton, and it is in the direction of 30 degrees northeast. 30 degrees northeast. 30 degrees northeast. So I'm locating the first force P now. 30 degrees northeast. So measure from the, measure from the vertical. This is 30 degrees, from the vertical, and the 30 degrees is measured. Now P here, force P here is 24 Newton. So, if from the vertical here, this line of action of force P is 30 degrees, then the same line of action would be 60 degrees from the horizontal. 60 degrees, that is starting from 90, 60 degrees. So that is good. That's the location of that force Q. Force Q, we are told, is 60 degrees southeast. Southeast. Again, we measure 60 degrees from the vertical. This is 60 degrees. This is Q is 30 Newton. And this angle measured from the vertical is 60 degrees. Then if you take 60 degrees from 90, what you have left is 30 degrees to the horizontal. So that same force Q is 30 degrees to the horizontal. This is the location of the given forces. So the first question is that we should find the horizontal and vertical component of the resultant force. So what do we do? The resultant force that is T minus X, that is Y, that is Y, so that is that direction, same direction, which is force P. Force P, we said this is 60 degrees, and that is P equals to 24 Newton. So now, to find the horizontal component component of this force P, both the horizontal and vertical component, we drop a perpendicular, the head of this force P is here. So we drop a perpendicular from the head of that force P downward. Drop a perpendicular downward so that a right angle triangle is formed. Now, if the horizontal component, this is the direction of the horizontal component of that force P, we can denote it with F sub S, maybe X of P, for force P. So we want to find the value of this F sub X P. And this will be the vertical component, F sub Y P, the vertical component of force P. Now, in that right angle triangle, this will be the direction of that horizontal component of force P, and this will be the direction of Fy sub P. So, in that right angle triangle, adjacent to the angle, this Fx sub P is adjacent to this angle 60 degree. So adjacent to the hypotenuse is cos. So cos 60 degree, cos 60 degree is equals to F sub X P over 24. Over 24. So if I cross multiply, I have F sub X P will be 24 cos 60 degree. Cos 60 degree is half. So that is 24 times 0.5, and that would be 12 Newton. So that is the horizontal component of that force P. Then the horizontal component of force Q now, the horizontal component of force Q So for force Q, I have this. That is force Q. Q is equal to 30 Newton. See, this one is 60 degree. The remaining angle here will be 30 centimeters now. So again, to find the horizontal component here, I drop it perpendicular from the head of that force Q to the x-axis. The x-axis. So that this direction is the horizontal component of force X sub Q. So this is the vertical component of force Y sub Q. Now, the horizontal component for force Q, I have cos 30 degree. Cos 30 degree is again adjacent over hypotenuse. That is F sub X Q over the hypotenuse is 30. So this means if I cross multiply F sub X Q equals to 30 cos 30 degree. That is 30 times 0.866.
25.98.
25.98 Newton. So then the summation now. Therefore, summation f sub x. Summation f sub x will be f sub x p plus f sub x cubed. So summation f of x now will be, this one is 12 plus 25.98. So summation f sub x is equals to
37.98.
37.98 Newton. So that is summation f sub x. So I have to do the same for the vertical component. To do the same thing for the vertical component. Can you decide?
Yes.
Same thing for the vertical component. So, the vertical component, I have this is for force P. Force P, this is X. This is Y. So, I have can you use the same data? I don't need to draw another data. I use the same data because it's clear there. So, the vertical component of force P. So now I have sine 60 degrees. So this is the vertical component of force P. Sine 60 degrees. Sine 60 degrees is equals to f sub yp over 24. Yes. So this means that if I cross multiply now, f sub yp is equals to 24 sine 60 degrees. That will be 24 times 0.866. I think so.
Yes.
So what do we have?
You have 20.78.
20.78. And then the vertical component. The vertical component of force Q. Force Q. Force Q. So I have for force Q. For force Q, I have sine 30 degrees equals to f of y cubed over 30. So if I cross multiply, I have f sub y cubed is equals to 30 sine 30 degrees. That will be 30 times 0.5, which is 15 Newton. Therefore,
Summation.
Summation f sub y now. That will be f yp plus f yq. 20.78 plus 50. You know?
Has to be minus.
Huh?
Minus.
Okay.
1 is negative.
Oh yes, yes, you're correct. So that is
That
that
of-
of Q is negative.
Yes.
So that is plus in bracket minus 15. Yes. Minus 15. Minus 15, I hope. So that is 20.78 minus 15. And that will give us 5 point,
7, 8.
5.78 Newton. Yes, so now this answers what I want to do. This is for 1 Roman cube. For 1 Roman cube. I can clear the other side, right?
Yes.
Then who will want to go now?
I want to go to the magnitude. Okay, you can clean the middle.
Okay, I can clear the middle.
Okay.
Okay. Right. The magnitude of the resultant force now. Okay, I should not clear this side.
No, okay, you can clean it. You can clean anyone.
You have not covered this.
We have covered.
So now magnitude of the resultant force R. So here R is equal to the root of summation f of x squared plus summation f of y squared. So R is equal to the root of summation f of x squared.
37.98 squared. 37.98 squared.
37 what?
98.
Square plus
5.78 squared.
5.78 square.
Yes.
So R is equal to the root of
1442.480.
1442.
1442. 0.98. 0.48.
That is the equal.
Yes, 0.48.
48
Yes.
plus
Then plus
5.78 square.
The answer is 33.41.
3.41.
Yes.
That's only.
The answer is 1475.
147.
5.
5 what?
0.89.
And the root of that.
The square root is 38.42
That's 8.42
Newton.
That is the magnitude of resultant force.
In the direction of the resultant force.
Can you this side, right?
Yes.
But you are holding it firm, right?
Yes. I am.
If it the hard surface. Direction. Resultant force. Now, to find the direction of resultant force, we have to draw the vector diagram first. Now, summation f of x is 37.98. That is summation f of x, 37.98. And which is positive. It is positive. So I draw that since along the x-axis, and it's positive, I draw that straight line towards east. That is in the direction of the positive direction of the x-axis. That is my summation f of which is 37.98 Newton. So that is then summation f of y is 5.78, which is positive. It is positive also. Because it is positive, from the head of this first vector, I draw that summation f of y upward. That is in the direction of the y-axis, positive direction of the y-axis. From the head of the first vector, I draw the second vector vertically upward. That is in the positive direction of the y-axis, since it is positive. So this is summation f of y, which is 5.78 Newton. So now these are the two vectors going. So then I have to close this polygon. I close the polygon by drawing the third. That's by drawing the resultant. Vector. So this resultant vector, now in which direction? It should be upward in order to nullify the effect of these two other vectors. So the direction should be upward. This is the resultant vector. So, and they are at this summation f of x and summation f of y are at right angle to each other. So now, let the angle between the resultant and the horizontal be theta degree. Now I'm calculating the direction. The question is, find the direction of the resultant first. So this is how to go about it. Now, tan theta in this right angle triangle, tan theta will be opposite over adjacent. So that is summation f sub y, over summation f sub x. Now summation f sub y here is 5.78 Newton over summation f sub x, which is 37.98 Newton. Newton will cancel Newton.
0.1522.
Tan theta is equals to 0.1522. So theta now will be tan inverse. Theta will be the tan inverse of 0.1522. So tan inverse of that
8.65 degrees.
8.65 degree. So that is the value of theta. But okay, now we can say that the direction of the resultant force is such that it makes an angle of 8.65 degree with the horizontal. So, but we can also describe it as this is northeast. So we can say that the resultant force, therefore the resultant force is 8.65 degree northeast. You can show it this way, or northeast or
this northeast. If you say the direction is 8.65 northeast, that suggests
no, sorry.
You have to subtract from 90.
And I've captured it.
You can just correct it. I stopped it. You can say you
Okay,
can correct it. No, don't clean it yet. Write it back. You can go back and correct it. You can just correct it immediately. Yes. Write it back. Write your
8.65.
Write it back. What you just cleaned. I want you to correct it because I've captured it. I've taken it.
This one already.
But it's not far. You can just say, oh, you have to subtract it from 90 degrees.
Okay.
It has to be subtracted before you can say northeast.
Yes.
Or do you think it's okay like that? You can.
No, it's not okay. Because it has to be measured from the vertical.
From the vertical.
So
you can write it back and correct it again.
Okay.
I mean, what you just cleaned. So you can.
The resultant force. Yes, this we have already captured it.
Yes.
The resultant force is 8.25 northeast.
Okay, let me start. Okay.
Northeast. Or see. Or the resultant is 8.65 degrees. So the resultant, is it not?
Yes.
To the